Right, we are given these three questions to do, A, B, and C, and we're supposed to solve for x using the K method. In A, we have x squared minus 2x equals 18 minus 45 over x squared minus 2x. In B, we have x squared minus x plus 4 over x squared minus x equals 4. In C, we have 3x squared plus x minus 1 plus 1 over 3x squared plus x minus 3 equals 0. And now, to proceed and solve these, we proceed as follows. Right, first things first, we solve the problem in part A. So we have A. And in A, we have exactly x squared minus twice x. And this is exactly equal to 18 minus 45 divided by x squared minus 2x. Right, and we let k be exactly x squared minus twice x. So that what we then have is that k is exactly 18 minus 45 over k. Right, we multiply through by k, both left and right, multiplying each term through by k, like so. Right, and upon further examination, we can see therefore that this is k squared equals 18k minus 45. Okay, so this is what we have got exactly. So now, what do we do if we have k squared equals 18k minus 45. So what we do is we transpose the terms, getting k squared minus 18k plus 45 equals 0. Right, so what we then do here is to solve this particular equation. So we look for two numbers because when we multiply the k squared with 45, we get 45k squared. We look for two expressions whose product is 45k squared, but whose sum is minus 18, and those are exactly minus 15 and minus 3, and therefore we're getting here k squared minus 15k minus 3k, right, plus 45, and the result is 0. We take out a common factor k from the first two terms, and we have k minus 15, like so. You have minus 3 into k here, minus 15, like so, and this is 0. Now, k minus 15, folks, is a common factor, meaning we have k minus 15 into k minus 3. We have factorized this expression, and then we get k equals 15, or we have that k equals 3. Having those two values, we need to remember next things that but we have that x squared minus twice x is equal to k, so that it means therefore that we have x squared minus twice x is equal to 15, or we have x squared minus twice x is equal to 3. All right, so we have x squared minus twice x minus 15 equals 0, or we have that x squared minus twice x minus 3 equals 0. We look for two numbers. If we multiply the first, the x squared and the minus 15, we get minus 15x squared. And so we look for two expressions whose product is minus 15x squared, but whose sum is 2x. And those are exactly what? They are exactly minus 5x plus 3x minus 15 equals 0. Right, and then upon factorization here, we can factor out x, having x minus 5 we factor out 3 here. We have x minus 5 equals 0. And we have x minus 5 into, you have x plus 3 equals 0, which means x equals 5 or x equals minus 3. And now we look at this. So if we multiply the x squared with the minus 3, we get exactly minus 3x squared. So that you look for two expressions whose product is minus 3x squared, but whose sum is minus 2x. And we can see exactly that those are exactly what? They're exactly minus 3x plus x, like so. And we have minus 3 equals 0. And therefore, we have x into x minus 3. And then we have x minus 3 equals 0. Okay, now we have x minus 3 here. And we have x plus 1 equals 0, which means that x is 3 or x is minus 1. Okay, so we have got the values of x out of this particular equation, and there are 4 of them. All right, now we look at the next question. What is the next question? So the next question is the part B question. What is the part B question? So part B says we need to solve for x given x squared minus x plus 4 out of x squared minus x, and this equals 4. Now to solve this for x, we use the k method. We let k be x squared minus x so that we have exactly k plus 4 out of k equals 4, and we multiply each of the terms by k like so. Right, multiply through by k, like we do here, each of the terms by k, because k is the lowest common denominator, the LCD, getting k squared plus 4 equals 4k, and this is exactly k squared minus 4k plus 4 equals 0. So what do we do here? Okay, we have here in the part B, we have k squared minus 4k plus 4 equals 0. And now we multiply the 4k squared by 4. We get 4k squared. We look for two expressions whose product is 4k squared, but whose sum is minus 4k. Those are minus 2k. So we have minus 2k plus 4 here equals 0. We factor out k. We have k minus 2. We factor out here with k minus 2 equals 0. And this is k minus 2. And then we have exactly k minus 2. And then this means k equals 2 or k equals 2. Now, what do we remember with this? Now, we have this, but we know that x squared minus x is actually equal to 2. Is actually equal to k, first things first. Okay, so is first equal to k here. So that what we have is that x squared minus x is 2, or x squared minus x is 2. Okay, so we have that one. So we are continuing with the part B, and we can see that x squared minus x equals 2, or x squared minus x equals 2. And this means x squared minus x minus 2 is 0, or it means x squared minus x minus 2 is 0. We multiply x squared by minus 2, we get minus 2x squared. There's those two expressions whose summation is minus x, but whose product is minus 2x squared, but whose summation is minus x. And those are what? They're exactly minus 2x, like this, and plus x. Minus 2 equals 0. And the same applies this side here. Minus 2x plus x minus 2 is 0. Okay, so you can factor out here, having x minus 2 plus x minus 2 equals 0, which means x minus 2 into x plus 1 equals 0, which means x is 2, or x equals minus 1, or x into x minus 2 plus x minus 2 equals 0, or x minus 2, x plus 1 equals 0. We have x equals 2, or x equals minus 1. So we have x equals 2 or x equals to minus 1. And these are the solutions to the second question, part B. And it remains to focus on the last part, here, the part C of the problems. Right, so part C is 3x squared plus x minus 1 plus 1 over 3x squared plus x minus 3 equals 0. And what is this? This is exactly the same as 3x squared plus x minus 1 plus 1 out of 3x squared plus x minus 1 minus 2, and the result is 0. Upon further examination, we let k be the same as 3x squared plus x minus 1, so that we have k plus 1 out of k minus 2, and the result is 0. And then what do you do here? We have k into k minus 2 plus 1 out of k minus 2 into k minus 2 equals 0 into k minus 2. Right, so we multiply it through by k minus 2, multiplying both sides of the equation, but simultaneously multiplying each term of the expression. So what is this? Now, this k minus 2 cancels, and we have exactly in the part C, k into k minus 2. We have seen that this is going to be exactly 1, and this equals 0. And this gives us something. What does this give us? So it gives us k squared here minus double k plus 1 is 0. And what do we do now? We multiply k squared by 1. We have k squared, and we look for two expressions whose product is k squared, but whose summation is minus 2k, and those are exactly minus k plus 1 equals 0. K into k minus 1 minus into k minus 1, and the result is 0, meaning we have k minus 1 into k minus 1 equals 0, and this means k is 1, or k equals 1 as well. Right, and that is what we've been able to achieve. And we need to proceed to sort of simplify this. Okay, but what do we know? We know that 3x squared plus x minus 1 is actually k, so that now, because 3x squared plus x minus 1 is k, we can equate the 3x squared plus x minus 1 to 1. Okay, so that in part C, we have 3x squared plus x minus 1 equals 1, or we have 3x squared plus x minus 1 equals 1. This is exactly 3x squared, like so, plus x minus 2. Right, minus 2 equals 0, or we have 3x squared plus x minus 2 equals 0. Meaning we have 3x squared. Multiplying the 3x squared by minus 2, we get minus 6x squared. We look for those two expressions whose product is minus 6x squared, but whose sum is exactly x. And those are exactly 3x minus 2x. Minus 2 is 0. Or this side here, this is exactly the same thing. So we have exactly 3x minus 2x minus 2 equals 0. Okay. Now we factorize 3x here is a common factor, giving us x plus 1 minus 2 into x plus 1 equals 0, which means you have x plus 1 into 3x minus 2 equals 0. And this means x equals minus 1 or x equals 2 out of 3. Or obviously here now we have the 3x, we can take it out as a common factor so that we have x plus 1 minus 2 into x plus 1. Okay, this equals 0. And so as a consequence, we have x plus 1 into 3x minus 2 equals 0. Or now this means x equals minus 1 or x equals 2 over 3. Okay, so we have solved all these equations in detail using the most famous K method of solving algebraic equations. In particular, this K method enjoys much celebration in equations that actually involve what you call rational functions. What are rational functions? So now these are those particular equations that involve a function f divided by another function g of x, etc. And now these are called rational functions. So these equations obviously basically were just involving rational functions, and we have been able to solve them in detail. Thanks everybody for your time and attention, and goodbye to you.